This question is to evaluate a specific integral using the method of trigonometric substitution. The integral of 1 divided by the quantity x squared times the square root of x squared plus 16 with respect to x. First step is to choose a trigonometric substitution. Because we see a square root of the form x squared plus a constant, it is helpful to substitute x with 4 times tangent of theta. That means dx becomes 4 times secant squared theta d theta. This also means x squared becomes 16 times tangent squared theta. The square root of x squared plus 16 becomes 4 times secant theta. Next step is to rewrite the integral using theta. Now we rewrite the entire integral in terms of theta. The denominator becomes 16 times tangent squared theta times 4 times secant theta, and dx becomes 4 times secant squared theta d theta. Putting it all together, we now have the integral of 4 times secant squared theta divided by 64 times tangent squared theta times secant theta d theta. Simplifying, we get the integral of secant theta divided by 16 times tangent squared theta d theta. Next step is to use identities to simplify. We recall that tangent squared theta equals secant squared theta minus 1. So the integral becomes secant theta over 16 times the quantity secant squared theta minus 1. Alternatively, we can express the integrand using sine and cosine. This results in cosine theta over sine squared theta. So the integral becomes 1/16 times the integral of cosine theta divided by sine squared theta. Next step is to use substitution. Now, let us make a substitution. Let u equal sine theta. Then do as cosine theta d theta. That makes the integral become 1/16 times the integral of 1 divided by u squared do. Integrating 1 over u squared gives negative 1 over u. So we now have negative 1 divided by 16 times sine theta plus the constant of integration. Next step is to convert back to x. Since we originally said x equals 4 times tangent theta, we draw a right triangle with opposite side x and adjacent side 4. That makes the hypotenuse the square root of x squared plus 16. Therefore, sine theta is x divided by the square root of x squared plus 16. Substituting back, we get the final answer, negative 1 divided by 16x times the square root of x squared plus 16 plus a constant. When you see a square root of x squared plus a constant, use x equals a times tangent theta. This turns the square root into a neat secant expression, which simplifies the integral greatly. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much.